This is my Lab 2 video report. First, I'm gonna do a Lab 1 summary since this lab is related to the Lab 1. And then I'm going to do an introduction of this lab. And then explain the physical principles and the calculations and computational model. And then I'm going to answer the reflective questions. So in lab 1, we float one tape over another by charging both tapes, and then assume there's only one charged particle on each tape. Based on that information, we compute the model, and based on the model on the left, we calculate the charge on tape B. So this is the introduction of Lab 2. The purpose is the same as Lab 1 to determine the amount of excess charge on one piece of clear tape. However, unlike Lab 1, we will use a line of charge to calculate the charge. In Lab 1, as I described before, we use only one charge to calculate the charge for the entire tape. So the method, we will first float one tape over another as we did in lab 1, and then record all the measurements like the mass of the tape, the distance the tape flows, and etc. And then we'll put those measurements into the coding to generate a model. So the result of this lab is the estimated net charge of the tape is 4.97 times 10 to the negative 8 coulomb. So now I'm going to explain the physics principles that I used in this lab. First is the Coulomb's law. I use this to calculate the electric force and then the electric field of the tapes. So Coulomb's law states that electric force equals to Coulomb constants times the charge of the first tape and the charge of the second tape over the distance squared. And then I use Newton's second law to calculate the gravitational force of the tapes because using mass times acceleration. In this case, it's the gravitational acceleration. And then based on Newton's second law, there's always an action and reaction pair. I can assume that the electric force is equal to the gravitational force. And then the conservation forces says that charges can only be transferred, not destroyed nor created. And then superposition of charges says that all infinitesimal charges adds up to the total amount of charges on an object. So using the conservation forces and the superposition of charges, I can then calculate the amount of total charges that is on the one clear tape. So this is the model that I created using my code on Go script. So the red circles represents the charges on the up tape, and the blue circles represent the charges on the bottom tape. The yellow arrow represents the gravitational force, and the white arrow represents the total electric force, and the green arrow represents the electric field on the up tape. And the magnitude of the electric force is 5.88 times negative 10 to the negative 3, and the magnitude of gravitational force is also 5.88 times 10 to the negative 3. So here's my code for recording the measurements. M equals to the mass and the charge of the tape, and then the function that helps me to calculate the electric field for one charged particle, and then the code for creating the two lines of the tapes, the red line and the blue line, and then the start position for the top tape. The y component of that is the distance that my up tape are floating from the bottom tape. So this segment of code shows the arrow scale for my electric force vector and my electric field vector. The function here loops through each piece of charge in the top tape, and then iterates through each piece of charge in the bottom tape, and then using the Coulomb's law to calculate the total electric field on each charge, and then add those up to generate the total amount of electric field of the entire tape, and then use the number for electric field to calculate the total amount of electric force on the tapes. Okay, so here comes the reflected questions. The original charge I got when modeling the tape as a single point charge is 2.4 times 10 to the negative 8. The new charge I got when modeling the tape as a line of charge is 4.97 times 10 to the negative 8 coulombs. This number is about 2 times larger than the result I got from lab 1. So I think these two numbers are different because the result from lab 1 failed to consider the interaction between charges and the result of superposition of charges, whereas the result from lab 2 did, which makes the result from lab 2 much more accurate.